Thank you. Good evening. Thank you. That was an incredible introduction. I hope I will. Anyway, so thank you for being here, and I'm very honored to be here. And it's my first time in this area. So I'm slowly visiting different parts of the U.S. So I wanted to tonight talk a little bit about, in a way, what I do, and some of the things that that happen to Arduino that are kind of evolving right now, and the way we are evolving our way of working and what we are discovering along the way. So this picture is the picture of the Interaction Design Institute Ivrea. So this blue building used to be the R&D department of Olivetti in the 50s and 60s and until probably the sort of 80s. And so at some point at the beginning of in 2000, they decided, Telecom Italia, the phone operator, the former sort of state-run phone operator of Italy, decided that it was probably a good idea to give back to the city of Ivrea, where Olivetti has sort of been slowly kind of reducing his workforce and sort of being slowly downsized year after year, to give back by creating a design school but not looking at the classic design that people do in Italy, because unfortunately a lot of the great design schools in Italy are still teaching very classic, very conventional ways of looking at design. So they wanted to try something different. So they said, okay, let's try with interaction design. Let's try to create a program that's just for interaction designers. And so through a number of fortunate coincidences, I ended up knowing about this place, and I sent this letter saying I would really like to work there. And probably the letter that I sent to try to kind of convince people that they should give me a shot was probably one of the best things I've ever written in terms of passion, and because I really wanted to try to do something with them. And so in a way, my job was to work with students that don't have a background in technology. They're not software developers, electronics engineer, and try to work with them so that they develop the ability to use technology as a creative medium. So one of the things I like is the idea that you can use technology, software, hardware as a creative tool. And in order to use it, you don't really need to become a full-blown sort of electronics engineer. There are techniques that you can develop where you can build things. Obviously, you still need electronics engineers in order to take projects to the further down to completion. But in a way, there's a lot you can do using technology as a creative medium. So a lot of the students do a lot of this kind of stuff. So this is a prototype of some kind of a, this is coming from K3, which is a university in Malmö, Sweden, where one of my friends teaches. And this is some kind of a helmet that kind of reverses sound and vision. And so, but this is interesting because there's this kind of metal mesh which is coming from some chicken coop and a bucket. But the idea is that if you have an idea, you should prototype it as fast as possible with what you have available and start to validate that idea and refine. So this idea that you build, test, repeat, build, test, repeat is ingrained in the way we do interaction design. So one of the things that happened in Ivrea is that I had the perception that if you're trying to teach something new, you also need to try to figure out if there are new tools for that. So we were very lucky that we had Casey Rees from the MIT as a professor that brought this programming language called processing that was very promising as a tool to teach artists and designers how to program. And so this diagram that was designed by one of my former students shows through the years all the different projects we did and the different platforms. So wiring was the platform that sort of came before Arduino. Programma 2003 was the platform I did before wiring. And then they converge onto Arduino over there. So this is a map we tried to do to figure out how all the different projects we did throughout the years, they sort of converged to this objective of figuring out a simpler, quicker, cheaper way to do prototyping with technology. So, and I think the results came out the way it is because it's 5 of us that kind of worked on it. So there is me, David Mellis, who's now a PhD student at the MIT Media Lab, Tomaigo, who teaches at the ITP in New York, Gianluca Martino, who deals with all the manufacturing, distribution, so he's the one that makes sure that we can make these boards and make them available to people, and David Quartiers, who teaches at K3 in Malmo, Sweden. So the 5 of us met in Ivrea in different circumstances, and we sort of started working together on Arduino. And then, so the tangible manifestation of Arduino is this little board, the size of a credit card, which is essentially a very simple computer, the same kind of computer that you have in a microwave oven or something technically, in a way, simple, yet it's an everyday object that has a little bit of intelligence. And this kind of small computers used to be very complicated to program. It was something that only engineers could do. And then slowly, technology evolved and it became simpler and simpler. So we designed this board essentially with the goal of providing a tool that would get you up and running as fast as possible. One of the biggest issues when you create tools for beginners is that if there are big barriers to entry, if the learning curve is too steep at the beginning, people give up. They think this is not for me, it's too complicated, I don't care. No? So you need to give some kind of a moment of, some moments of joy very early on in the process. No? When people learn about Arduino, the first thing they do, they blink that yellow LED called L near what it says 13. And when they blink that, they say something is happening, they made it happen. And so this kind of tells them, well, I can do this. If I apply, I can do this. So what are people doing with this? Well, what happened is that as it escaped sort of the academic world, it started to become used by people also that were not interaction design students. And so people started making all sorts of crazy machines. So this one is called the Inebriator, and it's a robot that makes cocktails. The interesting thing is it's got this kind of moving axis that reminds me of some of this industrial machinery, but applied to cocktails. So, and I like the idea that somebody kind of went through the process of designing this complex system to, that they had this idea and they could kind of carry it forward. Then obviously that kind of ability to control movement precisely becomes useful in product like this. This is an Ultimaker printer, and it's an open source 3D printer. So 3D printers have been around for a long time. So they are machines that you give them a file, and they can print an object out of plastic. These have been around for a long time. What happened that was very interesting in the last few years is that as a lot of the patents around this process started to expire, people started to make machines. They started off with the RepRap, and then other different models out there. They made open source printers. So the design of the printer is open source. So they created a whole community of people. They were developing ideas around this process, making printers that cost $500. So when you have a printer that costs $500, maybe the quality is not great, but you have it, you can have it on your desk. The moment you can have it on your desk, a whole, the game changes. You can start experimenting. And I think it's similar to the feeling that people had when in the 70s, they said, we should have computers that you can just have at home and they only cost a few $100s. And then, they kicked off a whole revolution. Another area where the technology behind Arduino is used a lot is this special type of helicopters called quadcopters. And this kind of helicopter wouldn't be able to fly if it was just kind of driven by a human being with a remote control. It needs a certain amount of technology in order to stay stable. So there's an Arduino-based circuit called ArduPilot or ArduCopter that kind of collects a bunch of sensors and keeps this thing stable, and so that you can make it fly. And you can see a picture of somebody's backyard.
All right, it's recording.
and they're flying this quadcopter. So the interesting thing about this is that it starts off as essentially people having fun as a hobby. And then after that, it becomes something that, okay, becomes a business for the people who design these things and sell them. But then there's other people who think, okay, if I have a cheap helicopter that costs only a few $100, can be charged by solar power, and basically flies by itself, then I can invent a service that will deliver medicines to villages in Africa. So a lot of people are starting now to imagine what is the next level. How can I use this technology to do something that is not just having fun with the technology, but the next step. And so Arduino found its place in weird situation like this one is a picture of the Large Hadron Collider in Geneva. And the scientists used Arduino to collect some information from some of the equipment. So I was in Geneva a couple of months ago, and one of the scientists told me, yeah, well, we used Arduino because it was cheap and simple. And also we knew that when we turned on the collider, the radiation would kill all the equipment down there. So, the Arduino was essentially an expendable piece of technology. We knew it was gonna die. And then they were surprised that actually the Arduino lasted for 2 weeks. So it lasted 2 weeks of high energy bombardment before giving up, which I think it was an interesting result. Also, it's being used by people to develop machines like this. This is an open source machine, so the hardware, the software, the design of the object is all open source. It's based on Arduino. And it's one of the machines you use in the process of analyzing DNA, when you want to amplify the DNA samples. So this is something that you can build yourself. You don't need any kind of professional equipment. You can make it yourself. And it opens the door, for example, to interesting movements that are happening right now called DIY bio. And so there are people who are gathering to experiment with biology the same way that people hack with electronics. And I was in GenSpace the other day in New York, and they do this. They have a space where people get together and they do these kind of experiments. But two things from this website as important themes that you will see in the rest of this presentation. When they say, okay, let's work together, they say, first, join the global discussion. So this movement that you can call the maker movement, kind of where Arduino found itself as one of the sort of founding elements in a way, has this idea that you discuss and collaborate with people globally online, but then you also find people and events near you. So you work with people in local communities. So I want to think it's very important in the maker movement is this idea of working globally online with people and then working locally, creating local communities. And some other quick examples, somebody built this glove that can understand sign language, and it can actually speak the words that somebody's trying to sign, and it displays it on the LCD screen. So again, this is this idea that you can prototype ideas very quickly and figure out if they work. Another theme which is very sort of popular at the moment is the idea of Internet of Things. This is the botanicals is a special kind of Arduino that measure different kind of parameters of this plant and tweets. So it might tweet things like, it's very dark in here, or I could use some water now, So the way that you kind of give your plants some kind of a personality, it's the moment where you start to relate with the plant in a completely different way. And again, this was an interesting project that they did at the ITP as part of a class. And then they made a kit that you could buy for $99 and assemble it yourself. And another project from the ITP, from my friend Benedetta, is that she worked to design this collar that it's used in Africa to track lions. Because again, problem is like lions come in and they eat all the animals that the village is carefully raising, and they come in and they just, eat all of your food. So they're kind of working at these kind of tracker devices specifically for lions. And now Benedetta was studied at the ITP. She's doing a lot of work of applying interaction design, Arduino, open hardware for places like the UNICEF and different other sort of institutions. Another interesting project that I like is when the Fukushima disaster happened, a lot of people started to feel that the government wasn't providing honest information about the amount of radiation. So what they did, they started to build these Geiger counters based on Arduino. And then they used, this is a design derived from what we call the Ethernet shield, which is a module that you put on top of Arduino to give it the capability to connect to the internet. So they manufacture a bunch of these boxes who measure the Geiger, so the radiation, and they push it onto a website where you can actually see an aggregate and actually a detailed map of the radiation. And they were able to demonstrate that the radiation was, the levels were actually worse than what the government was saying. But they manufactured these boxes, boom, locked them, shipped them out, people turned them on. And it was completely a grassroots thing from the ground up. And it's all open source, and you can go online and find all the design of this thing if you want to make one. Other quick projects, this is a clock that in a way visualizes where people, the members of this family are by analyzing their Twitter feed. So each hand represents a person. This is a kind of an art project, but in a way, to me, it summarizes a bunch of the technologies that, in a way, interaction designers and artists have developed in the last few years to make their life simpler, put together. So you have Arduino kind of controlling the robotic aspect of this thing, and then you have processing, doing face tracking. So by putting together this technology, a group of art students were able to actually create a robotic lamp that actually understands if there's people and what they're doing. And so they gave a complete set of behaviors to this device. And to me, this is interesting because this is something that a few years ago would have required a bunch of serious engineers to do. And now with the work that has been done, this is becoming possible for a group of students in a class. So this is for one of the areas where I work with my students, this idea that let's assume that objects in the future are all connected to the internet, and they all have behaviors. It's interesting to imagine that your lamp has a behavior. Maybe you buy a lamp, and when you buy it on the box, it says this lamp is a bit of a pain in the neck. No? And you can buy a lamp that has a personality that kind of suits you in a way. So I was obviously very surprised by the amount of crazy projects that people did with Arduino. And so as it sort of escaped the academic world in a way, and sort of people started to use it in their profession, to do DIY, to do hacking. They used it for all sorts of, I mean, once I tried to do a presentation trying to cover every single area of where Arduino is used, and it was something like an hour and a half of examples, and I thought no human being should endure such a torture of like watching hundreds of. So I'm glad that it became a tool that can unlock the creativity of people. They get the idea to people that you can actually, first of all, you can make stuff, even if you're not like a high-end engineer. So you can create. And also this concept that Arduino, I will show you now, it's very much deeply we're connected with the open source movement. So this idea that you don't need anybody's permission to create something amazing, because everything is kind of explicitly out there, open for you to use. So one of the features that made Arduino different also, apart from the sort of ease of use and everything, is the fact that the design of Arduino itself is open source. So Arduino is one of the first examples of open source hardware. So this is a picture of the CAD software that we use to design Arduino boards. And so you can download the files, you can make it yourself. And so this, in a way, creates this feedback loop where by sharing everything you do, you convince people that they should share as well, that they can take your work and modify it, improve it maybe, and then kind of release it as well. And Arduino itself is essentially an experiment in interaction design. There are all these technologies underneath Arduino, and so the work that was done with wiring, with Programma, Java, the GCC compiler, processing, all of these is wrapped into a platform where the innovation in Arduino is mostly the user experience. So the technology is there. It's very powerful. But I remember when I started working on Arduino, I saw this page from some guy from the MIT saying, oh, using AVR processor on macOS is very simple. And then there was like a 1 kilometer long web page detailing how you should compile your own compiler. And I didn't succeed, and I've been developing code forever. And I was like, you know, for them, simple means something which is incredibly complicated. So in a way, the idea was try to make something that creates a user experience by building upon incredibly powerful yet complicated pieces of technology. So Arduino itself is based on the fact that the hardware is released as Creative Commons. The software is released using the GPL license and the LGPL license. The documentation is also Creative Commons. Only the brand Arduino is trademark, to make sure that we can actually, you know, clearly say, this is what we are doing. And if you want, you can buy a board made by somebody else. It's perfectly natural. It's important to have multiple ways of getting your hands on technology. But then we wanted to clarify who we are and what we sort of contribute in a way. And it really became a tool, this idea that it's open and it encourages sharing and it becomes a tool for innovation. Really, it's participating in a process that you could call the democratization of innovation, which a lot of aspects have been foreseen by the work of this professor called Eric von Ippel. You can actually download his book from his website. And there's all sorts of interesting insight on this idea that people, regular people, are now participating in innovation. And I was very much influenced by this TED talk by this professor, Joanna Blakely, that she was looking at how fashion deals with brands and deals with copy, and how the brand is, you know, in a way, very important as a way to differentiate yourself. And actually, the fashion industry can't really trademark and protect the design of a garment. They can only protect their name, and they make much more money. Of all the industries who are aggressively protecting copyright, they make much less money. And these people that can't protect their designs are making a lot more money. So clearly there is something there. So in a way, we try to apply design quite a bit to the things we do. We work with people who make their own variation. This is a special Arduino designed by a professor at MIT that's designed to be placed inside garments. People are making their own Arduinos. And obviously we have these interesting Chinese companies that are building clones of Arduino, where they copy all the graphics and everything. I mean, consider the graphics in Arduino are not available. You can't download them. So in order to make it like this, you have to try to copy it. They do a fairly bad job, but then when they advertised on eBay, they say the official version, which is the official copied version. And then they stretch as far as selling boards that say made in Italy. The best part, they copy everything, including here it says Impatto Zero, which is a company in Italy that will basically offset the carbon emissions made to produce this board. So they don't even know what it is, and they just put it on the board. But in order to have that name on the board, you need to pay quite a bit. So every Arduino has his carbon offset by this company. So in a way, it's funny how people are just copying everything. But then if you look at the map of Italy, it's all crazy. Like Sicily is pointing, I don't know where. Like Sardinia is like pointing at Tuscany, like, you know, I'm coming to get you. You know, it's Apulia is kind of disappeared. So it's, again, it's an interesting sort of copy. So in a way, we started to look at how we can design the shape of the circuits to give it, since the circuit is kind of naked, can you work on the design of the circuit? And also we work with this brilliant designer, Giorgio Olivero, They used to be one of my students in Ivrea that developed a whole sort of graphic design around Arduino and all these little things we put in Arduino. And also we designed our own tape that says we love open source. So when you buy like a big box of Arduino, you get this tape on it. So the model in Arduino is that we design and companies make. We now start to become a global group of companies. So we have headquarters in Switzerland and in Boston, but then we have like physical spaces where we combine our office with some kind of a maker space, and I'll show you a little bit better what that means, in Torino, in Malmo, and we are opening one in Bangalore at the beginning of May. And we have Brooklyn on the map as the next place. And there's also a lot of stuff happening in Brazil right now. And the green dots are essentially factories that are making Arduino boards right now. So we kind of license the design to people who make them and sell them, and they give us a small royalty that keeps the project going. So these are some pictures of the factory that makes a lot of the Arduinos in Ivrea. And I like this idea that you can still make something in Europe, or you can still make something, because the Arduinos at the moment are made mostly in Italy and in Colorado. These are the two places. But I like this idea that you can manufacture locally, and that it shouldn't be a problem to pay a few dollars more if you know that something is made, locally, that it maintains a kind of healthy cycle. And we wanted to have much better connection with the local communities. So we started off an experiment in Torino called Officina Arduino. Officina in Italian is a workshop. It's like a small factory where people sort of are building stuff. So the Arduino workshop in Torino, it's the first of a series of places that we are opening where we're trying to combine, let's say, an office where people work on Arduino with a makerspace and a fab lab where people can come and work with us and use our tools and sort of learn techniques from us. And it's also a good way for us to collaborate. So Torino is, in a way, the Detroit of Italy. Fiat was huge. Everybody used to work for Fiat, and then Fiat kind of scaled down a lot. So there was all these buildings left and all these people. And it's been reinventing itself a lot. And there's a lot of these buildings, like this one is the diagram of a building that contains a co-working. And they gave us a free space that you can see where the finger is pointing, which is the Fab Lab and Arduino hackerspace that's connected to this co-working. And this used to be a Fiat factory that was renovated, and we have this warehouse they gave us for free, and we made this space where you have machines like laser cutters, and the people there, they engage with the community, they work with the community. So this is one of the big, one of the people from the community that started coming. Franco, the guy that's soldering, just came over to kind of play around, and now is the people who was one of the guys are teaching people how to do things, and he's kind of giving back to the community by helping. We do all sorts of projects. We work with design students, because again, in Italy, design is still thought in a very conventional way. So students don't see a laser cutter. They sometimes don't even have a proper modeling lab in the university, because you're not allowed to touch anything. So there's a lot of theoretical design going on. So they come there to the Officina to just learn how you do design in this century. And sometimes they come up with this interesting thing. So this is a case for an iPod made out of bamboo. But the interesting thing is that this bamboo is not like something that was it's actually a piece of wood that's normally, I think it's called baseboard. It's that kind of strip of wood that's kind of on the floor. And so they found a bunch of these, and they started to mill it, and they made like a case, and it became a design that kind of people started variating and manufacturing. For a few weeks, everybody was making this kind of stuff. So it's interesting how they come up, they find materials, and they kind of build upon that material. They did all sorts of projects by customizing design objects. This is stuff that the community is doing there. Or there's a fashion studio that figured out that using the laser cutter, they can do work that they cannot do with normal tools. Or some people are making bronze cast starting from 3D printed objects. So this is lost wax process. They do a lot of workshops and teaching people. And also we have this machine where you buy candies, where you can buy Arduinos. So we wanted to have this idea that technology should be something that you just go there, you press a couple of buttons, bzzzt, you can get an Arduino at every time of the night. So that you can, the same way you can ruin yourself by eating junk food, you can also get something good like an Arduino. And also the people there, they spend a lot of time going around Italy. They do these Arduino tours where they go around Italy and they teach in different cities. And they do workshop with people like Joseph Prusa, who makes open source. So it teaches people how to build their own 3D printers. They build a bunch of tutorials. This is the tweeting lamp. They also design their own furniture and they open source it. So these drawers have been designed there and open sourced on Thingiverse. They also participate in local activities, like, for example, Domus Magazine, which is an important design and architecture magazine based in Milan. They wanted to do an exhibition about makers and how makers impact design. So they asked Officine Arduino to give them a hand, and they built this big exhibition with lots of examples of Arduino-based products. And everything in the exhibition was sort of open source in a way. Even these tables, the tables in the exhibition, were designed by Enzo Mari in 1974 in this book called Autoproduzione, where he was starting to experiment with the concept that they could get this book for free from him, or almost for free, and then they would get the instruction on how to build every kind of pieces of furniture just with strips of wood that you could, and nails. So this table is also sort of a very early example of open source design. So as I said, we're also working with makers in India. So this is Priya. She's a 24-year-old engineer we met in India, and she's opening one of these Officine Arduino in Bangalore, which opens at the beginning of May. And so we did the same. We wanted to extend the experiment, and we found another place, which is Sweden. So my friend David teaches in Malmö, in the south of Sweden, which again used to be a big industrial city because it was a huge shipyard. And then at some point, making large ship basically moved to other countries, like to Korea. So they were left with no industry, and they had to, again, rebuild themselves from scratch. So the building that you see in the picture here used to be the place where the workers in the shipyard, they would go to kind of change, get a shower, and sort of relax between shifts. So it's a strange wedge-shaped building that actually is like 3-floor underground. And the city made it available to people as some sort of an informal maker space where people can do stuff. And Arduino kind of is taking over a piece of it to organize activity. So these are some of the desks where the people work there. The furniture is also sort of made with different materials. They have a small fab lab downstairs. They do a lot of teaching activities. This is my friend David, teaching people how to use GSM to design devices that communicate over GSM. And at the moment, they are doing a lot of work at producing education materials. So this idea that not only you provide tutorials for the people who want to learn, but then you need to provide materials for teachers so that teachers learn how to teach in the way that we do it, which is sort of informal. We don't do tests. We don't do, there's very little lecturing. It's mostly based on making stuff and evaluating the stuff that people do. So this is a set of things that you can manufacture with a laser cutter using Arduino and sensors that was actually made for a region of Spain, region of La Mancha, actually contracted the office in Malmö to design a whole curriculum for teachers, but not just a curriculum, to generate a methodology that the teachers can use to create their own curriculums So in a way, you know, what we're trying to do is always like not just produce something that's, you know, done. This is the textbook, follow it. We try to distill methodologies and give people the tool to produce their own stuff. So you can see some of the examples. These are little silly robotic devices that they have built. The kids can actually manufacture with the teacher. They put them together and they do all sorts of funny behaviors, and each one of them teaches different elements of electronics, software, digital fabrication, simple mechanics. So in a way, the idea is that the maker movement has helped a lot of people essentially enter the world in a way of interaction design, create their own company, being very successful at imagining new scenarios. And so we want to teach these less formal, less, you know, rigid methodologies also to kids, because I think that if we keep them flexible when they're still young, they won't be, you know, they will stay creative also when they're older. So I think it's a big challenge, but I think it's incredibly fun to be part of all of this. Thank you.